So, thing is, you got to know the difference between a definition and a property. And to help you with that, I'm going to be highlighting my definitions yellow, and my properties I'm going to be highlighting green. Okay. And what I highlight in yellow are the definitions that some of these definitions are a little extra long, and I'll only highlight the parts that I need you to memorize. Okay. So if there's something that I don't need you to memorize, I won't highlight that part. Okay. So this unit is on quadrilaterals, and so what is a quadrilateral? So a quadrilateral is a four-sided figure. Okay. There are some specifics to that, because what do you mean by a four-sided figure? Somebody may think, well, this is a four-sided figure, right? But that's not a quadrilateral. There's four segments and it's got four sides, but it doesn't fit some of all these things. So not only is it a four-sided figure, but opposite sides don't share a vertex is important. Opposite angles don't share a side, and angles that share a side are consecutive angles, and so that kind of rules out some weird pictures like that. Okay, but the only thing that you need to memorize is that quadrilateral means four sides. Okay. So that's a definition. A property is something that can be proven from a definition. So here is a property for all quadrilaterals. The sum of the interior angles of a quadrilateral is 360 degrees. Here's why. So if I draw any four-sided shaped figure, look something like that, okay? And if you draw a diagonal to opposite angles, it cuts it into two triangles. And what's the sum of the interior angles of a triangle? Right? This triangle, the sum of the angles is 180 degrees. So like angle A, angle B, and angle C here, those measures add up to 180 degrees. And then the bottom triangle, also, if you add like angle D, angles E, and angle F, you're going to get 180 degrees. Well, if you take that dividing line out, you'll notice that angle A plus angle F is one of the angles of my quadrilateral. Angle B is the other angle. Angle C plus angle D is the third angle, and angle E is the fourth angle. And we know the sum of all six is 180 plus 180, which is 360, right? And so that's all it comes from. And you could do that with anything. If you had like 5 sides, you can cut that into 3 triangles. So it'd be 180 plus 180 plus 180. If you had 6 sides, you can cut that into 4 triangles. So it'd be 180 plus 180 plus 180 plus 180. And it's just an easy way to tell you what's the sum of the interior angles of a sided figure, how many sides you have. Okay. Next definition, a parallelogram. So first of all is a quadrilateral, which means it's got 4 sides, and both pairs of opposite sides are parallel. So if on a quiz I were to ask you to draw, if I gave you 4 sides and I said, mark on here the definition of a parallelogram, well, you would just do this. Well, this side's parallel to this side, and this side is parallel to this side. And that right there would qualify. That's all you need to show me it's a parallelogram. Okay, because that's the definition of a parallelogram. If we start with that, we can prove 4 things. We can prove that opposite sides are congruent. That's a property. We could prove that any pair of consecutive angles are supplementary. We can prove that opposite angles are congruent, and we can also prove that the diagonals bisect each other. When we get to section 5.2, you're going to prove most of these properties. So what does that mean? Well, opposite angles are congruent. Well, opposite sides are congruent. If I have a parallelogram, that means these two sides are going to be matching, and these two sides are going to be matching. Any pair of consecutive angles are supplementary. What does that mean? If I have angle A, B, C, and D, so you need a pair, so that's two. They have to be consecutive angles. So in this picture, which two would be consecutive? B and what? B and D would not be consecutive. They would actually be considered opposite angles. What do you think would be consecutive? B and C. So any two angles along a side. So pick a side, any side, and what two angles are connected to that side. If you did angle B plus C, you get 180, which is because it's supplementary. Or you could say B and what? A. Those would be supplementary. Those would be considered supplementary. Or we could go A and D as well. You could say D and C. Are there any other pairs? Or did we get them all? What's that? Am I missing any, or did we get them all? Got them all? Okay. So those are the four sets of consecutive angles that we're talking about. Well, there's four sides, so we got four. That makes sense. We got them all. Okay. Opposite angles are congruent. So that would mean these two angles are congruent, and these two angles are congruent. And diagonals bisect each other. So if you draw your two diagonals, they're going to cut each other in half. So one diagonal's cut in half, and the other diagonal's cut in half. It doesn't mean that the diagonals are the same length. It just means they cut each other in half. Okay. So those are the four properties that you have to know that go along with every parallelogram, and you have to know the definition of a parallelogram. Okay. A rhombus is defined as a quadrilateral, so it's got four sides, and not only does it have four sides, but all four sides are congruent. So the definition would look like that. You got to use the same mark on all four sides. Okay. And you could prove a few things. So if you just start with that picture, you can actually prove that that's a parallelogram. Which means all the four properties of a parallelogram apply to this. So if you show something's a parallelogram, you can grab those properties from before. So opposite sides are congruent. Well, we already know that. Any pair of consecutive angles are supplementary. Okay. Opposite angles are congruent, and diagonals got to bisect each other. We can also prove a few other properties, that the diagonals are perpendicular, and that each diagonal bisects a pair of opposite angles. So parallelogram, diagonals perpendicular, so you just draw the two diagonals, put a perpendicular sign there. And then each diagonal bisects a pair of opposite angles. So here's a diagonal. So it bisects this pair. So the diagonals of an angle bisector, not only on one, but on the other as well. Should I use two markings or one marking? Am I allowed to do this? Why not? Are opposite angles congruent? Why are opposite angles congruent? It's a parallelogram, and in a parallelogram, opposite angles are congruent. So if these angles are congruent and I cut them both in half, are all four pieces the same? Yes. So we can do that. How about this? Can I do this? No, because we don't know that all four angles are the same. But all four of those pieces are going to be the same too, because these opposite angles are congruent, these opposite angles are congruent. And so that's what happens in a rhombus. Then we have a rectangle. The definition of a rectangle is a quadrilateral with four congruent angles, and each of those, because they're congruent, and because all four add up to 360, you can easily get that they have to be 90 degrees, okay? So picture looks something like this. You could do, I'll accept a couple pictures. You could do that for the definition, or you can actually show me that they're 90 degrees. I'm okay with either of those pictures, okay, for the definition. So what can we show if we start just with that? What can we prove? Well, we could prove that first of all, it's a parallelogram. So all four properties of parallelograms apply to these. Second of all, we can prove that the diagonals of a rectangle are congruent. So there's a parallelogram. And diagonals congruent, that's a harder one to draw. So here's what I'm going to do. I'm going to draw the diagonals. I'm going to label them A, B, and C, D. And I'm just going to state that AB is congruent to CD. Okay. Does a rectangle have to be a rhombus? No. Does a rhombus have to be a rectangle? No. Does a rectangle have to be a parallelogram? Yes. Does a parallelogram have to be a rectangle? No. Okay, so knowing the relationships between these things is something that we want to get straight as well. And I'll give you a little diagram at the end of this to show you that. Now, definition of a square. A square is a quadrilateral, so it's got four sides, and it's got four congruent angles, and it's got four congruent sides. What does it mean if I just said four congruent angles? What would that be the definition of? That's a rectangle. If I just said four congruent sides, what would that be the definition of? Rhombus. So another definition of a square would be a square is a rectangle and a rhombus. Okay, it fits both of those. And I'm not listing any properties here, but a square has the most properties. It's got all the properties of a rectangle. It's got all the properties of a rhombus. And because those are parallelograms, it's got all the properties of the parallelogram. So everything we've highlighted green so far applies to a square. Okay. A square is, another name for a square is a regular quadrilateral. That word regular means all the sides are the same and all the angles are the same. There's only one kind of regular quadrilateral. If I said a regular triangle, what would it be? The equilateral triangle, because all the sides are the same and all the angles are the same. So that word regular means all angles and all sides are the same. Trapezoid. There's a few things to know about a trapezoid. So in terms of a definition, you want to know a trapezoid is a quadrilateral. It only has one pair of parallel sides, not two. So is a trapezoid a parallelogram? No, because a parallelogram has two pairs of opposite sides parallel. A trapezoid can only have one. You want to know that the non-parallel sides are called legs, and that the parallel sides are called bases. And that the two angles that share a base of a trapezoid are called base angles. And I'm going to draw a little diagram to go with this here. So it's a quadrilateral, so you got four sides. Only one pair is parallel, and the parallel sides we call base. So we got two bases. The non-parallel sides are called legs. That's a leg there, and that's a leg there. Okay, and then along the base has two angles on it. So like base angle A, angle B would be the base angles for the bottom base. Angle C and angle D would be the base angles for the top base. If I asked you just to draw the definition, all you'd have to do is this. That's what that right there indicates. Well, that'd be enough for me, but also to be true to this, we'd have to also say that AB cannot be parallel to CD. So AB is not parallel to CD. Because if I just said AC is parallel to BD and just left it on, that here's AB and CD, then they could be parallel or they may not, right? But because it's a trapezoid, it can't be parallel. Because if it were parallel, it wouldn't be a trapezoid. Okay. Isosceles trapezoid, another kind. An isosceles trapezoid is a trapezoid that has legs that are congruent. So that picture looks something like this. You have your bases that are parallel, and then you have your legs that are congruent. And there's a couple, if you have that picture, there's a couple things that you can prove, or properties that you can prove. One is that each pair of base angles is congruent. Another one is that the diagonals are congruent. So these are specific to the isosceles trapezoid. They do not apply to every trapezoid. So each pair of base angles is congruent, so something like this. So if I had my angle A, B, C, and D, we have to know which ones are the base angles, so I have to show which sides are parallel. So this side's parallel to this. And so angle A is congruent to angle B, and angle C is congruent to angle D. And we had that with isosceles triangles, right? The base angles were congruent. So it's kind of an easy one to remember, isosceles trapezoid, isosceles triangles. And then the diagonals are congruent. We saw that before. What else had congruent diagonals? A rectangle, yeah. What else? One more thing. A square, because a square is a rectangle. And then the last shape that we're going to look at, the last quadrilateral, is a kite. And a kite is defined as a quadrilateral with two pairs of consecutive sides congruent and no opposite sides congruent. So if we were to draw something like that, it would look well, A, B, C, D. So AC would be congruent to AB, and CD would be congruent to BD. And that one mark could not be the same length as the two marks. Like sometimes in diagrams that look like this, they can all be the same. Like because you're using like a variable x and a variable y, and sometimes x could equal y. But by definition here, no opposite sides are congruent. So we'd have to say something like AC is not congruent to BD. Just to say that one mark is not the same as the two marks. Okay. And so that's the definition. And then one thing that we can prove with a kite is that the diagonals are going to be perpendicular. What else had perpendicular diagonals? Rhombus. What else? What? A square. Good. So diagonals perpendicular. That. Okay. All right. So I want to give you just a diagram that shows how all this is connected to each other. Okay. And you have a little space at the bottom of your paper, or you can put this somewhere else. But it'll be nice for you to have the big picture in mind. So quadrilaterals is what this is about. And if you have a quadrilateral, you can go a few different directions. You can say, well, you could be looking at a parallelogram. You could be looking at a trapezoid. You could be looking at a kite. Or just something else, but other. The three categories that we're looking at, though, in this class are the parallelogram, the trapezoid, and the kite. If you're looking at a parallelogram, you can go two directions. It could be a, well, two directions for this class. It could be a rhombus or a rectangle. Or it could be just a parallelogram that's neither a rhombus or a rectangle, so I'll just put other. And then if it's a rhombus, there is a potential that it could be a square. Same as a rectangle. If it's a rectangle, there's a potential it could be a square, because a square is defined as both a rhombus and a rectangle. But not all rhombuses are squares. You could have something else. Not all rectangles are squares. You could be looking at just a rectangle. If it's a trapezoid, it could be an isosceles trapezoid. Or just a trapezoid. And if it's a kite, it's a kite. We're not going to go any more specific than that. So the ones I'm highlighting are the key ones that we're looking at in this unit. There are other quadrilaterals out there, but these are the ones we choose to look at, and that's kind of the relationship. Notice that if you're working with anything in that parallelogram branch, you know it's not a kite, you know it's not a trapezoid, right? Because those are down other branches, right? And so on.